All right, we are from the Educational Technology Division, and this is our first attempt into data visualization. All right? Okay. Before I start, I would like to thank the National Research Foundation for providing us a grant for this project under the EduLab program. Right? This program is actually to help to surface and spread ground-up ideas on ICT innovations for learning. So we work with teachers to come up with their ideas to solve some of the teaching and learning issues, and we spread it out to other schools as well, right? This project, all right, is about applying data visualization for use during and after the lessons. So, in the context of just-in-time instructions for learning, and also in the context of students identifying the chemical formula and naming of the ionic compounds in the learning via a game called Right Formula. Okay, this is our flow. I will start with the right formula, which is a game. Why we develop the game, and how the game works, and then how it's used in the classroom. All right, and what are the shortcomings after we had developed the game, and then how we use data visualization to address some of those issues in the part. Right? Then we talk about teaching and learning, follow up with Q&A. Now, these are the 4 schools that are working with us in this project, and we have 5 teachers that are in this team that are with us today. All right, I think there is Zachary, Asmahan, Kising, Zhenjie, and Conrad. They are all here. All right. Okay, we developed this game to try to address the problem that students have difficulty with grasping the ionic compounds nomenclature, a chemistry subject, normally introduced in K8 or K9, all right? And when we discussed with the teachers were telling us that they normally do frontal teaching to teach this topic, and they provide students with lots of worksheets to consolidate their learning, all right? And a lot of the students were bored, and they are confused, and they are not motivated. So the team thinks of creating a game to motivate them, gamified it, right, to motivate them, and the game will provide instant feedback. The moment they choose a wrong ionic answer, the specific feedback will be given based on the error that we made. All right, and we also incorporate what I call the discovery learning approach, so that learning becomes more interactive rather than just hearing from the teachers. And together we had this project called Right Formula. All right, and this game. The standalone version of this game is available in the App Store or the Google Play Store. You can download it and have fun with it. All right? It looks more like an arcade game rather than the normal practice and drill type of game. Okay? Now, this is how it's being used, how the game is played. When you have this interface, the students can actually select the ions, the cations and the anions, and to submit it, all right? And if they have chosen the right combination, like balancing of charges, then they will be given the second screen that is on the right. We call this the MCQ screen, all right? Because it's a choice. So the students will choose to identify the formula and the name of the compound that they have formed, all right? In this case, since they click on 2 potassium, so it's K2S. And if their name is chosen correctly, it will be in red, followed by a feedback. All right? So how is it used in the class? All right? So normally what the teachers do will be to let the students play a couple of rounds. All right? Each round is only 90 seconds, so it's fast. It doesn't occupy curriculum time. And then the students will be given the opportunity to discuss among themselves the type of patterns that they notice, the type of rules that they may see from it. All right? And then follow up by a classroom discussion where teachers will co-construct the rules with the students. All right? And after that, the co-construction is what we call the use of rules. And then after that, the teachers will get them to play at a higher level, more difficult level. And then the cycle goes. All right? So for the game, there are 20 levels of difficulty. So you can go around for a while. Okay? Now, our initial first iteration of the content management system where we capture the students' moves are all recorded over here. It's a bit small. In this one, it's called the class summary. This shows the students' performance in the game, but it's based on each individual performance, all right? Later on, there will be a bit more details, so you can't see very well, it's all right, okay? And this is what we call the error analysis. The green represents that the students get it correct, and the pink color ones indicate they had chosen wrongly and the type of feedback that's given to them, all right? But it's hard to see, to get an overall view of how well the class is doing or what are the common mistakes made by the students, all right? So the team decides to do a second iteration and apply data visualization on this, all right? So Pei Xian will share more about data visualization.
Thank you and good morning. So as you can see from the two diagrams, the information is available, but it's not very easy to use for the teachers. So we started exploring data visualization for the purpose of sense making and communication, because we wanted it to be easier for teachers to make use of this information during the lesson. And we had a very, very specific target audience. We wanted it to be usable by the teachers. So we weren't designing this for the students, we were designing it very specifically for the teachers. So we had a very long process as a team to keep discussing what is important to us, what sort of features do we want. And at the end of it, we came up, when we looked back on that process and we were reflecting, we found that these were some of the questions that we kept coming back to over and over again. So the first question is, how do we know that our students have learned? Because as teachers, we are trying to teach something, whether it's the skills or the content knowledge. So if we want to know that the students have learned, what indicators do we have? Since we are making use of a game, what sort of data does the game collect? Is it the appropriate data, or is there something else that we need? And if we have the data, how do we process it to make it something that's useful for us? And at the end of the day, if you have all these nice things, how do you know that it's actually accurate? Because there's no point feeding the teacher inappropriate or inaccurate information. So this is just an example. Most of you are not chemistry teachers, I think. So if you have this list of correct answers and you have these 3 students, who do you think is a good student, or what is it that each student has not understood? So these were some of the examples that we talked through when we were trying to figure out as a team, how do we know that our students have learned? So if you look at the first student, 1 correct answer, 3 wrong answers. So this student has a very low accuracy at this point in time. The second student has 2 correct answers, 2 wrong answers. So maybe this student understands a bit better, but you don't have consistency in the understanding. And the third student has learned how to game the system. 4 correct answers, but it's the identical answer. So, if you look only at the percentage of correct answers, it's not good enough. So the 3 things that we thought would help us understand whether or not the students have learned, whether or not they can correctly identify the names and the formula of ionic compounds, whether they can consistently identify it, as well as the variety, whether they can demonstrate that understanding for a very wide range of compounds. And this actually fits very nicely with the kind of data that we have from the game. So we can calculate the percentage of correct answers. We can calculate what we call the streak, which is basically consistent correct answers. And we can also calculate the variety of compounds formed. So for these types of compounds, you can break it into different kinds of groups, and then you can count the number of groups that students have managed to form compounds in. So when you put all this information together, we use those 3 indicators to try and give a big picture view of what's happening in the classroom. So on the left-hand side, you have the original page for the class summary. On the right-hand side, you have the enhanced page. So if we go through the enhanced page in a bit greater detail, what we did was we did a pie chart that sorts students by the game difficulty level that they are performing at. So there are 5 levels, but in the pie chart, you only see 4 colors because one particular difficulty level is not represented. And the pie chart is just a big picture, what is the proportion of my students in my class at this point in time overview, but you have the actual numbers of the students. And the radio buttons are to let you select more information about the students. So in addition to which students are at which difficulty level, we also know within a difficulty level, how are the students performing? Are they meeting expectations? Are they exceeding expectations? Or are they just approaching expectations? So this allows the teacher to figure out very quickly who might need a bit more assistance, who might need a bit more attention. And if you click on each user ID, it will bring you to the individual student page so that you know exactly what the student was doing. And as Tong mentioned at the start of the project, we have quite a lot of schools, and we also know that the game is being used in a lot of different classrooms. So we wanted to make this customizable so that each teacher can decide how the students are classified into these different bands. So that's where we came up with our alert system criteria. So the 3 indicators that I mentioned just now, basically you can select which of these indicators you want, and you can also select the boundary conditions. So what defines acceptable performance, what is low performance, what is high performance. So over here we have 2 examples. The left-hand side is the original one. On the right-hand side, we have made the criteria slightly easier. So you need a smaller variety of compounds, you need a smaller streak, you need a lower percentage of correct answers. So for example, if a teacher was using this when students are first encountering ionic compound nomenclature, then you would probably be looking at a slightly more relaxed criteria. Whereas if you're using this at the end of the year when you're reviewing, when you expect that students have already mastered this, then you might want to use a more difficult criteria. So the effect on the pie chart as well as the alert system, you can see that some students have moved upwards. So from the approaching expectations, you have 1 less student, and then now you have 3 students in the exceeding expectations band when you adjust the criteria. Okay, so this is the class summary page. Then the other page that we wanted to show as an example is the errors analysis page. So again, originally we had just green and pink. So now we have it sorted by pie charts, and there are actually 4 pie charts. So we categorize the different errors that students can make into 4 possible baskets. And for each because this page analyzes mistakes, you want to know who was making the mistakes. So it actually counts number of mistakes made and how many users. So if this number of users is less than the total number of students in your class, then you know very quickly that not everyone was playing the game, or possibly not everyone was making mistakes, which would be a good situation. So for each pie chart, again, what we did was we singled out the top 3 mistakes within that basket. So in total, within the game, we've got about 21 categories of mistakes. But for a teacher looking at all 21 mistakes in a bar graph, it's not very useful information. So that's how we ended up sorting it out and prioritizing top 3 mistakes. And then for each mistake, there's a table that accompanies it that tells you what are the top 3 examples of mistakes that were made for this particular category, and who are the students who are making that kind of mistake and the frequency of the mistake. So this can be picked up for discussion in the classroom. So how do we know that all this nice errors analysis, class summary stuff is working. The way that we tested it was we defined a representative data set based on the different kinds of games you can play, based on the devices students are using, based on the difficulty levels. And then we play tested that data set and we downloaded the raw data. After downloading the raw data, we had to analyze it using a few different ways. So one was using this system we developed. Another one was the very painful pen and paper counting, tally charts, using Excel macros, things like that. And then we compare the different output, and every time it doesn't agree, we have to go back and check and debug. So at the end of the day, we are satisfied that we have come up with something that is reasonably accurate for us, for our purposes. So the pie charts that we are comparing all add up. The errors that students make are all accounted for. So at the start, Tom was telling you how do we use it in the classroom. So now, how do we bring the data visualization part into this whole discovery learning approach? So you can use it in the lesson. You can also use it after the classroom lesson. So we've shown you 2 pages. There are actually a lot of other pages, like there's a player summary page, there's a player's errors analysis page. There are a lot of other pieces of information that we have. So primarily from the class summary page during the lesson, one useful way that teachers can make use of this information is to decide how to adjust the difficulty level. So for example, if I think my students have studied this topic before, I set the difficulty level from level 1 to level 7. And then as the students play, I notice that there are a lot of people showing up in the pink zone. They're not meeting my expectations yet. Then I know, okay, maybe I need to adjust the difficulty level down to just 1 to 4, and I need to focus on ensuring that the foundation is there before I move on. Conversely, if the students are doing really, really well, that means I can move on to a more difficulty level faster. Another thing that the class summary page lets you do is, because you can negotiate targets, you can involve students in deciding what they think is an indicator of success. So at the start of the lesson, you can decide as a class, okay, maybe today we are going to focus just on percentage of correct answers. And then at the start of the lesson, we look at where everyone is. At the end of the lesson, we look at where everyone is. So that you can involve students in that process of setting targets. For the errors analysis page, obviously it lets you pick up the common mistakes, but in particular, because you're looking at students' current performance, there are time filters. The default time filter is actually 15 minutes from last activity on the teacher's summary page, so that I know exactly what my students have been doing for the last 15 minutes. But if I want to adjust it backwards to a longer period of time, that's possible as well. So this really allows you to address what students are doing at that point in time. Besides that, with the top 3 mistakes that are being made, you can pick out those mistakes specifically to guide students to look for patterns in the mistakes that are made, so that they can start deducing the nomenclature rules that govern how we use chemical names and chemical formulae. And then outside of the classroom lessons, when you make use of all the other pages, it helps you to design what you want to do next. It helps you to figure which students you want to focus on. And we've also had some teachers who use this to generate personalized error reports for individual students, so that the students can do it as a sort of personalized worksheet rather than just the general worksheets that we give to our students on a regular basis. So that's what we've done up to this point in time. These ways of using the content management system, we sort of came up with these ideas of how we want to try using it, and then we watched how our team teachers are using it, and we've been refining this list of strategies. And we are also currently trying this out with more classrooms. So we've been sharing this particular system with more school teachers, and we're finding out how they're using it as well. So that's it from us. And do you have any questions?
Do you have any questions?
Hi, very interesting work, and I really like the insights that you explained to us around the visualizations. And my question or comment at the same time is, if you are thinking about the next step to maybe include some of this rationale into the visualizations, because well, it was not clear if you present this to the teacher is immediately, or the students, they're immediately going to catch them, especially because using pie charts has been proved that it's not the best way to show information for comparison, for example. Or well, if you highlight certain things, maybe can help. I don't know if you have thoughts about future work for improvement.
Okay, when we use this with the teachers, we actually run a training workshop that's a 2.5-hour workshop with the teachers. So we run through the rationale for both the game and the content management system and how we designed it. We do recognize that pie charts may not be the best way of representing the data, but based on our conversations with the teachers with whom we developed it, it's something that most of them are familiar with, and what they want it for is just a very quick picture of proportion. So that's why there's the accompanying tables. If I go back to this slide here, there's the accompanying table that breaks down the actual mistakes that are happening. So the teachers actually find the table a bit more useful rather than just the pie chart. So the pie chart is just like a quick snapshot. And it is actually possible to download all the data for further analysis for the teachers if they want to actually do a more detailed study of what was happening. Yeah.
Any other questions? Okay, so I have a question. Maybe I missed. I mean, how long the students use this game? I mean, how many days or something like that? Yeah.
Last time the teachers used to teach this topic quite quickly because it's fronted teaching. But with this approach, they took about a week. But the students are really active, playing with the game for a period of about 2 to 3 weeks.
3 weeks.
2 to 3.
2 or 3.
Yeah, 2 to 3.
In
both in and out of the school. They can play at home.
At home. Okay.
Yeah.
And then show this pie chart to the teachers immediately after 2 weeks. Like,
No, the teacher have access to this content management system on their own. They can go in anytime to have a look.
Oh, anytime.
Yes, so the teachers can have a quick scan of the type of performance and the results before they go into class.
Thank you. Any other questions?
Thank you for your talk. I was wondering, do you have any idea on how often they actually look at the data and what they do when they have looked at it? Do you have any ideas on that already?
We don't capture this data, but you can ask them to see how often they go use.
Hi, my name is Zachary. I just used it last week because that's time to teach INEC formula writing to my students. And I'm checking this morning that less than 10% of my class is playing it, so I'll be reminding them. We do use it at a particular time of the year, but from observations we found that they do play just before the exams, and before major tests. I'm not sure my colleagues over here how often they use it, but during that 1 to 2 weeks of instruction, we do use it very regularly. It's I know pie chart is a bit dubious, but it's a very important tool for us. We are just regular teachers. I think in this room, we are probably misfits, not like any one of you. Okay, but when we hover the mouse over the pie chart, we do get a very clear idea of how the class is doing. And when we click further, we can identify specific students who may not have learned well conceptually. And in fact, this slide that Paysen is showing only the top 3 mistakes. There are other variety of mistakes that each particular student is making. And when I go into each individual profile, I discover deeper misconceptions among some students. So that's how I use it. Anyone else wants to respond to that?
Okay, let me just add on. How often I use it in class? I use it almost every 10 minutes when I have an hour of lessons, because there's different levels to it. So I actually make on-the-spot decisions based on level to level kind of mastery, and I know when exactly to move my student up to the next level, so that helps me a lot. At the same time, I was the one who generated the personalized report. It gives my student an immediate feedback based on their personal errors, and it generated a lot of interest, and they could see a lot of care, this personalized, humanized reaction through this report, which some of the limitations of the CMS that I have previously used could not do. Yeah, so my students were very engaged, and there was more meaningful discussion because the errors were based on real time. And as a teacher, I know that my intervention worked or did not work because, again, I can time filter everything based on action and time. Yeah, thank you.
Thank you. It's really nice to hear how actual practitioners are using this. I think that's a very valuable contribution. We'd really advise you to build on that. Thanks.
Okay, so any other questions? We have 3 minutes. Okay, no? Okay, thank you very much.